All right, so welcome to another video on this CompTIA IT Fundamentals Plus certification. This time we're going to cover Module 3, Unit 1, and we're going to be talking about system components. Objectives for this module. So at the end of this module, you should be able to explain the way in which systems components determine performance and how to specify an appropriate computer system. One of your tasks as an IT professional would be to recommend computer systems, based on the need of your client, of your, whoever it is that you are working with or helping. So you need to understand these components so that you can make the appropriate decision when you are buying computer systems. You should also be able to describe the types and functions of motherboards, processors, memory, and the expansion bus, which are the main components of a system. So basically, the power and the function of the computer depends on the power of these components. You should also be able to explain the importance of a cooling system and the components used. So as you may or may not know, but the inside of computers get extremely hot, and therefore you need to have a proper cooling system in order to accommodate for that. All right. You should also be able to identify the role of PC firmware and access the firmware setup program. So every computer comes with a piece of low-level software that it is accessed, it's before the operating system, and it has a whole bunch of low-level, again, functions, as I mentioned, on the PC. And so you need to be able to, there's a number of things that we can change over there in the BIOS setup, and we'll show how to do that also. So what are the kinds of things that you should take into consideration when you are selecting a computer? So what are the key components for performance? That's the first thing is the central processing unit, or CPU. This is considered kind of like the brain of the computer. Um, Another extremely important component is the memory, or system RAM, the amount of memory in your computer. And obviously fixed disk, the hard drive. The hard drives comes basically in two big flavors: the old traditional hard disk drive, which is the HDD. They have built-in platters. They are the kind of like the most common, the traditional hard drives. They are a lot slower than the solid state drive referred to as SSD. Now, obviously, SSD are more expensive, but you can increase the performance of a computer, I would say, like about almost 10 times faster just by buying a faster hard drive. A lot of the new computers, especially laptops and tablets, they already come with SSD. That's why a little bit, when you see an expensive laptop, most likely it would have an SSD drive. But if you have an older laptop that you've bought over the years and you want to increase the speed, buying an SSD drive is an option. Most likely you can replace the hard drive and have a faster computer. The other component that it's really good for performance is the graphics processing unit, or the GPU. It's basically the graphic card, especially if you're going to be working with programs that required intensive, graphics, like gaming, or anything that has to be with graphics and design and games and that kind of stuff. So basically, there are many components in a computer, but you could say that these four are the most important. okay, for when it comes to performance. The CPU, the RAM, the hard drive, and the graphic card. Um, Now, out of these components, what type of component provide persistent storage? And again, just to differentiate, because sometimes when we talk about memory, system RAM, people confuse, memory with hard drive. And the main thing is that the memory or the system RAM, it's random access memory. That's what RAM stands for. Everything that's in RAM, it's only while the system is on. If you power off the computer, if something happens while you're working on something and you have not saved, then it will be lost and you have to start all over again. Now, if you're working on a document and you save that document to persistent storage, like a hard drive, it could also be a USB drive or a DVD or Blu-ray, whatever. But it's important to understand that. What is a network interface card? Well, the name goes with it. We refer to this as the NIC. And there are basically two types, the wired network and a wireless network. So the wired network has an Ethernet port, which is referred to as RJ 45, which is this component over here. It looks like a telephone port, but this is a little bit bigger. The traditional telephone port is referred to as RJ11. And again, so this is referred to as a NIC, or a network interface card. All right. And then we have a wireless card. So if you have a desktop that's in the basement and it's difficult to run a cable to access your internet, to connect it to the internet, you could buy a wireless card for a desktop. There are basically two types. One that's internal. This is a PCI that goes inside the PC. But if you want a most modern one, you can buy a USB wireless card, and you can put it as in a laptop. Although most laptops already come with a built-in wireless card, but if it doesn't, then you can do that. Also, if you have an old laptop that has an old wireless card that it's not too fast, you could buy a faster wireless card and have faster internet, that kind of stuff. And another key component is what is called to as the wireless access point, or a wireless access point is mainly used in a company. In a home is referred to just as a wireless router. Okay. But again, so those are the components, or those are the features, the use of the network interface card, which obviously extremely important because everybody use networking. A computer without connection to the internet or any other network, it's useless basically for most of the stuff that we do nowadays. Let's take a look now at motherboard components, and this is what goes inside a computer, whether it is a desktop or a laptop. So first of all, we talked about how important the CPU is. There is a socket on the motherboard where the CPU goes, and some motherboards have more than one socket, especially the more powerful ones. Then you have memory slots where you would put your random access memory, or RAM. You have the disk connectors where you would connect the hard drives, right, for persistent storage. Then you have the adapter slots, right, for adapter cards, such as like video cards and sound cards and network cards. Now, for the most part, a lot of people do not use this anymore because a lot of the stuff, especially in home PCs, everything is basically, it's integrated. So most home user desktops or computer, they come with a built-in video port and built-in network or NIC, built-in sound, built-in almost everything. So you don't have to worry about this. But if you are a powerful user and you want a more powerful computer, let's say that you produce music, and you want, there are programs that are very sophisticated, and you want to produce high definition quality sound music, then most likely a built-in sound card, it's not going to be enough. And in that case, then you could buy a sound card to install it on your desktop. In your laptop, you are very limited, even though you could buy USB components. But basically, if you're going to do something powerful, just buy a powerful laptop. So what kind of question, one of the questions you might get, in the review question is, what computer component is most restrictive in terms of determining upgrade potential for a desktop computer? And again, it's the motherboard. So the motherboard actually is the most important component, because everything else basically goes into the motherboard, whether it is inside the motherboard or behind the case of the PC on the side, connected to this I/O ports and that kind of stuff. So now it is not very common nowadays to just buy motherboards and build a computer. It used to be very common, in which you would buy the components and then you would build your own PCs. But prices are so cheap in powerful computers that for most users do not need to do that. But if it's something that you want to do, obviously, I would spend most money on the motherboard. And let's say you cannot buy the most expensive CPU at this moment, but you buy a motherboard that supports one of the more expensive one, and then you can upgrade later. But if the motherboard doesn't support the kind of CPU that you want or the memory, then you're done. You're going to have to buy a new motherboard if you want to upgrade to a faster CPU that your motherboard does not support. Another question, true or false? A plug-in card, it's always required to support PC sound. And the answer is no. So this is false. And the reason this is false is because, again, as I said, in most computers, especially home PCs or low-end PCs, the sound card, almost 99% of the computers now that comes with the built-in sound. So you do not have to buy an expansion card for the sound. All right. Again, we talked about the processors and how they are kind of like the brain of the computer, extremely important. Processor is an integrated circuit, central processing unit. It's a main processor in a computer. Intel versus AMD. So these are kind of like, the AMD and Asus and Intel are the two main ones. So Intel is the main one. So actually, if you go to, let's say, to Amazon and you're looking for a CPU, what are the kind of things? Now, remember, this is mainly if it's a desktop. So the thing that you're going to look at, what brand, and there are other brands over there, even though Dell and HP and Acer, actually, they don't make CPUs per se. But what happens is that a lot of people refer to the CPU as the case of the computer. So that's why probably they have that over there. But in terms of CPU itself, you're going to be stuck with, these are the two main brand. And so take a look at this. Only this CPU costs, $370. So if you're gonna build a computer, powerful computer, it could be pricey. And it will tell you this is an Intel Core i7 9700K desktop processor. This one has up to 8 cores and up to 4.9 gigahertz turbo and all kinds of stuff. So it's a lot of specs over there. So in other words, that's a very, expensive and good CPU. You could buy by price. Obviously, you get what you paid for. And all the things over here. So let's say The Intel Core i7 are the more powerful, so they're gonna be more expensive. So if you're looking just for that, then you know it's the price are gonna go up. And here you can buy in terms of speed. So we could say that the speed of CPUs go from like 1 GHz up to like 4 GHz. And obviously, the faster the CPU, the more expensive. You could buy new or refurbished, and you know that kind of stuff. So important to understand those things when you are going to be selecting a CPU. So again, we just talked about Intel, AMD, CPU brands. There's a lot of legacy stuff, you know, like the Celeron and that kind of stuff. So these are other brand names for CPU. But if you want a good computer, then I personally I'm an Intel guy, so I usually go with Intel. All right. There's also what is called as the ARM CPUs. ARM stands for the Advanced Risk Machine or microarchitecture. They are widely used on smartphones and tablets. ARM don't make CPUs, but basically they just license the designs. And Apple and Samsung, and they use that kind of stuff. NVIDIA for video cards and other things. In terms of the architecture, we have what is called the RISC, which stands for the Reduced Instruction Set Computing. And so RISC microarchitectures are simple instructions, and they process very quickly. And then you have the CISC, or the Complex Instruction Set Computer. And there are more powerful instructions, but process each one more slowly. And the main thing is over here that normally, so the PC, the Intel compatible computers use the CISC microarchitecture, while the Apple used the RISC. And that's actually, so that's one important thing to differentiate among these two over here. So what are some of the features of processors? The control unit or pipeline, the execution unit, and the registers. Those are things inside the CPU, and that's how they process information. Not too much to go about that, especially for this exam. Instruction set. So we have already talked in previous units, we've talked about the distinction between a 32-bit and 64-bit CPU. So again, the important thing to remember is that the main advantage of using a CPU in a 60-bit mode is that they're faster, and you can put more memory on it. It's basically, that's what's used today. Unless you have a very old computer, the 32-bit, it's legacy stuff. That's old technology, very old technology. So important to differentiate that over there. And so how do you now keep in mind this also? The CPU has to be 64-bit. The motherboard has to support 64-bit, and the operating system or the software has also to be 64. Now, I have explained, I have said in previous lessons that you can have a computer system that is 64-bit architecture, and yes, install a 32-bit application, but you cannot do the other way around. So if you have an old computer that is a 32-bit architecture, you cannot install a 64-bit operating system. So how do you know? What kind of architecture is your computer? So let's take a quick look at this thing. So if I go to my computer and I right-click on this PC on Windows 10, so here I have, it says the system type is a 64-bit operating system. That means that this computer is 64-bit, because otherwise I wouldn't be able to install that. And while we're here, then here's my processor type. So this is an Intel Xeon, which is kind of like a server class processor. And here's the model and stuff like that. And this is a 3 gigahertz processor. I have 64 gigabyte RAM installed on this computer. This is a very powerful desktop. Again, here's the system type, and that kind of stuff. It's important to know where to find those things. So going back to the presentation, again, most PC and laptop, they're 64-bit nowadays. So no need to talk too much about 32-bit. What about the clock speed and the bus speed? So again, we talked about the clock speed. We talked about the 3 gigahertz. So clock speed differentiates CPU models. If you see the premium models, obviously they run faster, and we just said that in terms of speed, you can go from like 1 gigahertz to 4 gigahertz and change, right? Inside the CPU, we have what is called the front side bus, which is between the CPU and the system memory. And obviously, the faster the computer, the faster the front side bus. This is another key term to consider. But obviously, when you buy, a CPU with the fast CPU, then that comes with it. So what is a typical speed of a modern CPU to run at? And again, so we talked about this. So I would say, from 1 to 4, but the typical, I would say like around 2 or something. Mine is a 3 gigahertz, but this is a very powerful computer. So I would say that the average is that most people have computers that run like about around 2 gigahertz. But again, it depends on your budget. Multiprocessing and dual core. So symmetric multiprocessing, or SMP, what does it do? It basically provides multiple CPU sockets on the motherboard. So if you have a powerful motherboard, there may be more than one socket, right? And usually it's a feature of a service system or a powerful desktop. Other important components here are the chip level multiprocessing, or CMP, where basically each CPU contains multiple cores. Each core works as a more or less kind of like an independent CPU. And then you have, so when you're buying a computer, one of the features it's going to ask you is, do you want 2-core, 4-core, 8-core, and that kind of stuff. And obviously, the more cores, the more expensive it's going to be at. So in my computer, so how do I see how many cores my computer has, right? So if you right-click on here in the taskbar, and you go to Task Manager, and then we go to Performance. If you go to the CPU tab right here, let me just, so if you go to the CPU, you're gonna have the specs over here. And so this is what we're talking about. This motherboard, the bus speed is 3 gigahertz, right? Sockets, I only have 1 socket on my motherboard, but it has 4 cores, okay? And that's why you see the logical processor, because basically each core, it's kind of like an independent processor. It's important to, now that we're here, that most physical, this is my physical computer, and remember that as I have discussed before, I'm using virtualization. Now, virtualization is a feature that is not enabled in the motherboard. So it's something that if you want to run virtualization products like VMware or VirtualBox or Hyper-V, you have to enable that in the BIOS. And we'll see that later on, or if not in this unit, in this class. Here is the another feature of the motherboard and the CPU. It was called the type of cache memory. So there's L1, L2, and L3 memory, and obviously the more cache memory, cache memory is a very fast type of memory that it's inside the CPU and the motherboard. So the more cache memory, the faster and the more powerful your system is going to be. So very important to come to Task Manager to take a look at these things over here, because this will tell you a lot about the computer. So if somebody call you up and say, hey, my computer is really slow, it's not performing, so this is a place to look up and see what kind of motherboard and CPU they have. And obviously, memory is an extremely important component when it comes to the performance of the CPU. So here you'll see characteristics of the memory, the total amount of RAM, what it's available, what it's being used, and and that kind of stuff. All right. All right. So going back to our notes over here, systems and expansion bus technologies. So the motherboard is a printed circuit board with buses connecting processors and the data, address, timing, power. The system bus or front side bus, it's between the CPU and the system memory. We just talked a little bit about that. The expansion bus, which is the input-output bus, it's between the CPU and other processor as well. All right, so here is a graphic of a motherboard with a whole bunch of things over here, along the circuit. Not to worry, you don't need to know all these little things. Obviously, a lot of these things that they're just part of the motherboard. There's nothing you can do. You cannot replace. You cannot do anything with these things. So obviously, when a motherboard dies, basically the system dies, and you either buy another computer or you buy another motherboard and replace it if it's a desktop. Okay, but some of the major components, we talk about the memory slots. So this computer has 2 memory slots. So if this computer were to support, let's say 16 gigabyte RAM, then if you want to put 16, you got to buy 2 memory chips that are 8 gigabytes each. If you want to put 8, then you put 2, 4, and so forth. It all depends on how much RAM the motherboard supports. Okay. So, and then, we have the CPU socket. So this one has one over there. And this is what we refer as the North Bridge, which is this little chip over here. And these chips are nothing more than they basically support. The North Bridge, which is the front side bus, it's closer to the CPU. The South Bridge, which supports the speed for the other components, like the buses and expansion cards, then it's a little bit slower and it's further away from the CPU. All right, so those are the kind of things, there's a lot of other things over there that we're going to be discussing as we move along. So when it comes to expansion bus types, especially for the CPU, for the video card, the fastest is the PCIe 3.0, which goes like, actually there is the PCIe 2.0 times 16, which is up to like 16 gigabit per second. So the faster, the better, of course. So one of the questions that you might get is, if you want to purchase a computer with a fast graphics interface, what type of expansion slot should you look for? And the question would be, actually this has been faster because this is 1 gigabit per lane. And then version 3 doubles the bandwidth per lane again. So this would be the fastest of them all. So important to know that. Older computers, you're going to find it with the AGP, PCI. It's extremely old. So unless you have a very, very old computer, you're not going to get a computer with a video card with this. But there may be other components, maybe like a network card or that kind of stuff. AGP, it's for video. And then so the most modern is the PCI type of stuff, and so here are the speeds. It's important to take a look at that. You don't need to memorize. So one of the questions that you might gonna get is related to the speed and using this for differentiate. If you're gonna buy a powerful computer, what kind of PCI would you want to get? All right, so remember that I mentioned at the beginning that computers, the inside of the computer get extremely hot. So you need system cooling. System cooling comes in 2 types, a heat sink and thermal paste, which basically you have to put, it's this thing over here, this is the top, this is the CPU, this is the socket. So you put the CPU and you have to buy this thermal cooling that to put it on top of the CPU, because the CPU gets extremely hot. So if you put this without any, thermal paste, then that may burn the motherboard. All right. So again, heat sinks are referred to as passive cooling because they transfer heat by convection. Now, fans are referred to as active cooling because they are power. So you actually have a fan, and there is some power that is connected to this. Sometimes they get the power through the connector itself. So one question that you may get is, what type of component provides a passive cooling solution? And again, so heat sinks are, passive cooling, and the active cooling refers to as a fan, which is inside the computer. All right. Another important consideration is that to know that the case fans draw cool air through front vents and expel warm air through the back of a computer. All right. This is an example of a very high-end, especially like gaming computers, use liquid-based cooling systems. And again, expensive stuff. Now let's talk about the BIOS in the UEFI system firmware. It's basically two types. This is lower level software that is on motherboards, okay? Booting a computer is referred to as bootstrapping or just booting. And what happens is that, the CPU starts, initializes other components. The CPU, it's again, as I said, the main component of the computer. It occurs before the operating system loads. So before anything loads in a computer, that screen that you see over there, we'll see it in a bit. It's the system BIOS. It's controlled by PC firmware, so it's embedded into the motherboard. BIOS stands for Basic Input Output System. And so basically, to look at these things, you have to go into the BIOS setup, which we will take a look at. And then we have the UEFI, or the Unified Extensible Firmware Interface, which is, so the BIOS is a traditional, all kind of low-level software. Most modern PCs use this Unified Extensible Firmware. And, in the BIOS, basically, you have to use the keyboard to move around. With this newer version, you can navigate using a mouse. So here are some examples. So how do you access the BIOS of a computer? Well, it depends, but basically it's by pressing a key during this, the boot sequence, way before you see the operating system. If you see that Windows, then it's too late. You have to start all over again. If you look carefully on the screen, a lot of computers will display. So notice how most Dells you enter by pressing the F2 key. And what you do is you just keep on pressing that F2 repeatedly until you get to the system BIOS. Okay, and then you get to something like this. So again, this is like an old BIOS. So you would navigate this using the keyboard, the arrows, and the enter key, and that kind of stuff. So here is a computer with a most modern kind of like a BIOS setting, called the, again, UEFI setup programs. And so both the UEFI and the BIOS are, as I said, low-level software that it starts when you boot your computer, whether it is a desktop or a laptop. So this UEFI is just a kind of like a modern version, right? It supports larger hard drives. It's faster. It has more security features, and you can use graphics to move the mouse and stuff like that. So this is very convenient. So I like this kind of setup. This is an older kind of like where you have to move around, and basically says that if you make any changes, then you press the F10 to save and exit setup. And basically you're gonna have different menus. So you move around to these menus depending on what is it that you need to look at or change. There are certain things over here that are changeable. Other things are just for information purposes. But there's a lot of stuff that you can change on a BIOS. You gotta be careful, because if you misconfigure the BIOS, the computer may not function properly, or you may degrade the performance of the computer. But anyway, so if you messed up and you want to install over again, there is also a feature in most BIOS in which you can load the setup and the default setup, and it basically goes back to the way that it came from the manufacturer. All right, so that's it for this unit. When it comes to some, we're going to take a look at some the review questions. We kind of went over that, so that's basically it. Now, for this unit, there is a lab 11, which is specifying a piece of system, and that's on your test book. So go over that, and I'll see you in the next video.